Okay, mean, median, and mode and skewness. Whenever we talk about the normal distribution, okay, we're talking about an idealistic, pretty, perfect world, symmetric looking histogram, okay? And a histogram, remember, is just the length of the bar is how frequent that particular data or class appears. So if there's, two of them, then three, then four, then five, and that's the mode. And if five happens to also be the average or the mean, where we add them all up and divide by how many there are, and it happens to be the median, then everything is nice and symmetric. Okay, on a histogram, the mode is always going to be the tallest bar because it's the most frequently occurring data point or group of data, class of data, if you will. Now, if it's perfect, then the median and the mean will also be there. If it's not quite perfect and there's data that's trailing off towards the right, sort of like taking a blob of Play-Doh and pulling it to the right, it shortens this, and it also creates a tail. And so the median, then the middle of the data, the positional middle of the data, and the mean are probably also skewed this way. Now, I can't guarantee that that's 100% of the time always going to be true, but if things are not perfect, then it could be skewed to the right, or if you look at this one, it could be skewed to the left if the mean and the median are in this direction. So that's the skewness. And if you look at, and of course this is from your textbook, but if you look at the histogram maker that I created and the one that you play with, you'll notice that the data that I randomly generated doesn't create anything pretty at all, not even a slope. It's just chaotic up and down data. So that's what skewness is all about. Now, as far as why does the normal distribution look like it does, just has to do with the fact that if you were to have, and I scratched out these titles right here because I don't want to confuse you, but I love the pictures here. Again, this is in your book, but if we had a histogram of some data, and notice it's not perfect, but boy, it looks pretty good. And if you think about it, what this histogram is 1, 2, 3, 4, 5, 6, 7 groups, 7 classes, and this is how many data points were in each individual class. And again, if you look at the histogram maker and play with increasing the number of bars or the number of classes, then the more you increase it, the more often it's increased. Notice that it's still jaggedy, but it's resembling a normal curve more and more, and even more classes. I don't know how many are here, but notice it's still pretty jaggedy, but it's like pixels, if it's high definition versus low def. And if we were to chop this up an infinite number of times, I mean just chop, 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 it would actually become perfectly smooth, okay? And that's your normal distribution or your bell curve.